All right, team, settle in. We're going to dive right into the most fundamental part of our job, the materials we use. You know, what we choose, how we shape it, and why we choose it, well, that determines absolutely everything about the vessels we build. So let's just start with the big picture, right? What does it really take to build a modern ship? I mean, that's why you're here. You're the next generation of engineers who are going to be answering that question day in and day out. And look, the very first thing you've got to get in your heads is that this is so much more than just cutting and welding metal. Take a look at this stern frame. Every single piece, every curve, that's the result of a decision. And that is the core challenge you're going to face every single day. It's this constant balancing act between strength, weight, corrosion resistance, and of course, cost. Okay, so to really get a handle on that balance, we have to start with the undisputed king of the shipyard. Yep, let's talk about steel. And what's crazy is its history. I mean, for over a century and a half, 150 years, this stuff has been the backbone of pretty much every major vessel that's ever hit the water. Why? Because it's reliable, it's strong, and honestly, we understand it better than just about anything else. Okay, so here's the deal, and this is crucial. Not all steel is created equal. The stuff we use, it's low-carbon, mild steel. You need to burn this into your brain. That low-carbon content, we're talking 0.15 to 0.23%, is absolutely critical for one reason: weldability. You go any higher than that, and you're going to get cracks when you weld. It's a disaster. And one more thing. Every single piece of steel that comes into this yard has to be approved by a classification society. Think of them as the independent auditors of the sea. They make sure everything meets super strict international standards. There are absolutely no exceptions. But here's the thing. Steel isn't just one ingredient. It's more like dough. We shape it, we treat it, we cook it to do very specific jobs. A steel plate for the hull is a totally different beast from a propeller shaft, and that all comes down to how we process it. This is where we get to be both old-school blacksmiths and modern-day scientists. Heat treatment. This is how we tell steel what we want it to be. We can anneal it, heat it, and cool it slowly to make it soft and easy to work with, or we can normalize it, letting it cool in the open air to give it a nice, uniform internal structure. Then there's quenching. This is where we rapidly cool it in water. It makes it incredibly hard, but also brittle. So that's why we have tempering. We gently reheat it to relieve all those internal stresses. Mastering these 4 stages is how you get that perfect mix of strength and ductility for every single part. All right, so once we've dialed in the properties of the steel itself, we have to give it a shape, right? We do that by taking the treated steel and running it through these enormous rollers to form sections. And you can really think of these as the skeleton of the ship. They're what provide the core strength and rigidity for the whole thing. And you're going to see these everywhere. These are called bulb flats. When you see them welded to the inside of the hull plating or on the decks, you are literally looking at what keeps the ship's skin from caving in under the massive pressure of the ocean. That unique shape gives them amazing buckling resistance for how little they weigh. And these guys? Angle bars. They are our go-to versatile connectors. I mean, they're the workhorses we use for framing, for stiffeners, for connecting all the smaller components and supporting machinery. They might look simple, but they are absolutely essential. Okay, but what about those huge, complex parts that you just can't make with a roller? You know, like that stern frame we saw a few minutes ago. For something like that, we have to use casting. We literally pour molten steel into a gigantic mold to create that one single intricate shape. And of course, after it cools, it goes straight to heat treatment to make sure it's solid. Now, for the components that take the absolute most punishment, I'm talking about parts that have to endure incredible, repeating stress, like a propeller shaft. Casting just won't cut it. For those, we have to forge it. We are physically hammering and pressing the steel into shape. This process actually aligns the grain structure of the metal, making it unbelievably dense and strong. That's how you get superior tensile strength and fatigue life. A cast shaft, it would just snap under that kind of strain, no question. Okay, so steel is clearly the foundation, our main event, but it can't do everything. So let's talk about the specialized supporting cast, the other materials we bring in to solve very specific problems. So here's a classic problem. What if you need to slash weight way up high in the superstructure to improve the ship's stability? Well, say hello to aluminum. It's our lightweight specialist. Now, it's not as strong as steel, and yeah, it's a lot more expensive, like 8 to 10 times more. But its crazy low weight and natural resistance to corrosion make it an absolute game changer. And this number right here, this is why that high price tag is often worth it. You can save up to 60% of the weight by using aluminum instead of steel in a superstructure. Just think about that for a second. Every single pound you save high up on the ship lowers its center of gravity. What does that mean? It means a more stable ship in rough seas, better fuel efficiency, and maybe even the ability to carry more cargo. It's a huge trade-off, and it has a direct impact on both performance and safety. It's all about using the right tool for the right job? So for things like small yachts or fishing boats, we use fiberglass because it's lightweight and super easy to mold into complex shapes. For really specialized stuff where you need insane strength and impact resistance, we'll use composites like Kevlar or carbon fiber. And what about propellers? They have to survive spinning in corrosive salt water for decades. For that, you need copper alloys like bronze. Nothing beats their resistance to corrosion and wear. Which brings us right back to the most important point of all, and really the core of what your job is going to be here. Look, the real skill here isn't just knowing that these materials exist. It's about deeply understanding all of these trade-offs so you can make the right call for every single component. You have to ask, can it handle the stress? How much does it weigh? And how does that affect stability? How's it going to hold up in a marine environment? What is this ship even designed to do? And the big one, is the performance gain worth the cost? You're going to be asking yourselves these questions every single day. So think of it like this. These materials, they're your tools. The designs on your screen, those are your blueprints. The real question, the one that's going to define your entire career, is what are you going to build with them? Welcome to the team. Now let's get to work.